Hello and welcome to another LeetCode problem. Today we're going to be doing longest substring without repeating characters. It's a pretty straightforward problem, but it is going to help you make sure you can use a sliding window algorithm well along with some others. And so let's do that. So for this problem, you're given a string and we have to return the longest substring without repeating characters. So in this example, it's actually ABC because anything else would be repeating. And then in this second string with all B's, you can only have one B. And then in this PWW, KEW, you have KEW or WKE. There's going to be multiple there's going to be multiple results. As long as we return one of them, is totally fine. So how do we do this problem? It's actually pretty straightforward. So let's just take this first example. So we have ABC, AB, C, B, B. Let's actually space out these characters to make it a little bit easier to go through. So we have this string. And what we're actually going to do here is we need to make sure that we somehow figure out, we're going to go through the string and we need to figure out, did we encounter this character before? And there's two ways to do that, right? To encounter the character before, one way you could do it would be kind of a bad way, is you go through the string and then you just keep the whole string, right? So you go through ABC, let's say, so you have ABC, then you come to this A and you say, for every single letter, you just say, does my string contain it? Right, so you'd say does my string contain A? The problem with that algorithm is it would have to check the entire string, and so it's not going to be super efficient. So a better way to do that would actually be to have a set. And then what we're going to do is we are going to, so let's actually move this over here to the right so we have more space. Okay, and so what we're going to do is we're going to go through the string and we're going to have a sliding window, and then anytime we've encountered a character we've seen before, we're actually going to keep removing characters until we delete that character. Because if we encounter a character that we've seen before, that means there's only one character with a duplicate. So all we have to do is just make sure we find where that duplicate is, remove that duplicate, and then we have a valid string again. So what's that going to look like? Well, it's going to be pretty straightforward. So we're going to have a result. So let's just say we're going to have this res equals something. Then we're going to have a left and a right. They're going to start at both index 0. So we're going to left here. Right here, they're going to start index 0. Then we're just going to go character by character and add in the characters and then see if we've seen it before. So we're going to go through this character A, right? We're going to add it in to our set, and then we're going to update the result to be the biggest of what we've seen if we have a valid string. So right now we do have a valid string. It's just this right here, and so the result is going to be 1 because that's the length of A. And now let's move the right. So we're going to move the right over here. Right, so let's actually get rid of that right. Now we move the right over here. Now we add the B. And then we add, we haven't seen the B before. So let's just add the B into the set. And now our new result is going to be 2. Now we move over here. So now our right is going to be over here. And now our string is ABC. We haven't seen the C, so let's add this. And now this result is going to be 3. Okay, now we move our right one more time. And so our right's going to be over here. And now this A we have seen before, it's in our set. So what we need to do is we need to actually shrink our string. So our string is this. We need to shrink our string to have a valid string again. And so we're going to keep removing the left character and keep moving the left until we haven't seen the right character anymore. So what that's going to look like is we're going to remove this A from the set. We're going to move this left over here now, and we're going to shrink this string to this. And now we haven't seen the right character, it's no longer in our set, so now we can just keep going like we do normally. So we would add the right character in, so we add in the A, and then we would say how long is this string? Well, the string is length 3, but we already have length 3. So let's keep going. And so now we would move the right again. So the right would come over here. It would be over here. Now our new string is this, but we have seen this B. So now we have to do the same thing. We have to remove the B, and then we have to move our left. So our left is going to be over here. And now we haven't seen the B, so now we can add the B in, and our result is still 3, and this string is shortened. Okay, so now we keep going. So now we make the right go to the right one more. So it goes over here. Our string is this. and we have seen this C, so we have to remove it, and we have to keep updating the left until we haven't seen this C. So in our case here, like the left is always the character we're removing for the most part, but it could be like a C's over here. And then you're going to have to actually remove a bunch of characters. So you can't just remove one character here. You have to keep removing from the left until you remove that character that the right is. So we're going to move our C over here, or we're going to move our left over here. Inside our new string is this. Now we do have a valid string because we haven't seen this C, so we're going to add the C back in. So we're going to add a C, and then our result is still 3. Now we're going to move our right again, right? So our right is over here. But now we have seen this B, and so we're going to remove this B. Now you're going to see kind of like what's going to happen if the left isn't the first one we remove. So, or sorry, we're not going to remove this B because we're going to remove the left character, right? So we're going to remove this left character, this one right here, and then we're going to move the left. So we're going to move the left over here. We're going to remove the left character, which was actually A. So we removed A, but we still, like, the right character is still in our set. So we have to keep doing this until the right character is no longer in our set. So now our left is over here, so we have to do this again. We have to remove this character now, and then move the left one more time. So we're going to remove the character here, move the left over here, and now we have a valid string, and so this string is going to be over here. And then now we can put in our right character into these sets. So now we can put in the B, and that's only going to be 2, so we don't have to do anything there. Now we can move our right over here. And so now that we move the right, now once again, our character in right is in our set. So we have to move the left and get rid of this C. We have to move the left over here. But our character is still in our character in the right is still in the set. So we have to get rid of this character as well. So we're going to get rid of this character. We're going to move this left over here. So now the left and the right go in the same place. We add a B, and this length is only 1. And then finally, we return the maximum length. That's going to be kind of how the algorithm is. We can use a set to make sure we don't have duplicate characters, and we can just have a left and right pointer. Okay, so let's code that up. So we're going to have a set, so we can call that like duplicates maybe. Then we're going to have a left and a right. They're both going to start at 0, and then, yeah. So actually, by the way, a nice trick you can use is you can just use a left pointer, and then your right pointer can just be your right pointer can actually just loop through the string. So we're going to have a res. We're going to try to maximize the res, so we can just say it's 0 start. So we can actually do this. We can actually say for index value in enumerate s, and then our index. So this index is actually going to be the right. And so what are we going to do? Well, we're going to add. So first, what we need to do is we need to shrink. Remember, we need to shrink the set. So we need to say while v is in the set, so in dupes, we need to actually get rid of the left value and keep moving the left. And so let's do that. So that's going to be dupes remove, and it's going to be the left value, right? So SL, and then we need to move the left. Okay, so now that we don't have any more duplicates, now we can actually add the right value, right? So we can add the right value right here. So we're going to say dupes.add this value. Now we're going to maximize the result, so we can do that here. And this is going to be right minus left plus 1, as always in a sliding window. That's how you get the length of a sliding window. So this is going to make sure that our sliding window is valid. This is going to add our number to the set. This is going to give us our result. And now we don't actually have to increment R because we are literally looping through S. So that's a nice trick you can have if you don't want the left and the right. You can just, your right can just be looping through the actual object. If all you're doing in your object is just updating right by 1 and it needs to go through the whole object. Okay, I believe that's it. Let's take a look. Okay. And so let's think of the time and space here. So for the time, we are looping through S, so whatever length S is. So that's going to be O of S. We're looping through it 1 time, and we're not really doing it. It's a linear time algorithm because we have a sliding window. And for the space, we have a set. And worst case scenario, if you think about it, the set can have individual, like all the characters in S have to be unique. And so if all the characters in S have to be unique, then there can only be 26 characters, assuming they're all like lowercase letters or whatever. Like this digit symbol spaces thing is going to be some constant number. Let's call it 500, whatever it is, which is going to be O of 1 because it's just a constant number. Like there's only so many characters you can have. But if it's some big number, it would just be like, yeah, the number of possible unique English characters, including, yeah, like letters, spaces, digits, whatever this is. That's going to be for the space, because we do have this set that we're using. Okay, so that's going to be all for this problem. Hopefully you liked it, and if you did, please like the video and subscribe to the channel, and I will see you in the next one. Thanks for watching.